Okay, guys, welcome to week 4 Mathematics for Computing. So, this week we're going to learn something very simple. It's called partial fractions. So, first things first, we must know why we use partial fractions. Partial fractions is used to take complex algebraic fractions. For instance, let's say we have this fraction. When we integrate this, right? So integration is done so that we can find the area under a given curve or graph or equation. So you can make any kind of equations, right? So to find the area, it's much more easier if we can break this into smaller integrals and then integrate it. So that is partial fractions is one of the things that we learn that can make the integration process simpler. So first thing you should know when it comes to partial fractions is there are three types. One, there is just simple partial fractions. Then there is repeated partial fractions, and then there is I would like to call it mixed partial fractions. So what is this? Well, I'm going to lay down some ground rules so that you can understand a few things before we go. This is a bit unorthodox, but let's see how this turns out. So let's say you have an improper equation. Is it proper equation? Okay, a proper equation is when the highest power of the unknown variable on the top is lower than the highest power of the denominator, right? So I'm going to keep this simple and keep like this. So what we can do is, first thing we must do is we must see if the lower denominator can be factorized. So I don't know whether we can factorize this. So instead of factorizing this, let us simply select another one that we can know. So x plus 1, and below we have x plus 2 and x plus 3, right? So what we can do is we can write constants, and we can break this into different parts. Then what we do is we multiply, we equate everything, and then we solve for a and b. So here what we can do is we can get x plus 1 is equal to a x plus 3 plus b x plus 2, right? And we can actually write all of this out, and then we can compare coefficients. So comparing coefficient is like this. So we have a x plus 3a plus bx plus 2b. If we do it, we can write a plus b x plus 3a plus 2b. So now we can compare coefficients. So if we compare x to the power 1, 1 is equal to a plus b, and if we compare x to the power 0, which is constant coefficient, 1 is equal to 3a plus 2b. That is one of the way we can do it. We can solve the simultaneous that comes over here. Or we can do something known as the elimination method. So here we can say x is equal to negative 3. Now bear in mind, you can only use elimination method when you have the equation that you didn't derive it. Because if you derive it, there's a high chance that the equation may be wrong. So this equation is simple, it's already there, so you don't have to worry much. If you put x minus 3, so minus 3 plus 1 is equal to, we can forget this one because it becomes 0, right? Plus minus 3 plus 2 into b. This is a minus. So minus 2 is equal to b times minus 1. B is equal to 2. Then we can either go with, we can do the same elimination over here, or we can compare coefficients, and we can say a is equal to 1 minus b, a is equal to 0, because, oh no, a is equal to 1, my bad. So, and then we can rewrite this above equation as like this. So this is one way of doing partial fractions. And another way is, let's say we have a repeated term. Now this is repeated. We should write like this: a x plus 1 plus b x plus 1 whole thing squared plus c x plus 2. Solving it, I'm not going to explain, just you have to find the most efficient way to solve it. Let's say we have a denominator, a factor which can't be factorized. Now you can't factorize this. How do you know if you can or cannot factorize something? Use b squared minus 4ac. If b squared minus 4ac is greater than 0, it has two distinct roots, meaning it will break into two. If b squared minus 4ac is equal to 0, it will break into the same root. And if b squared minus 4ac is less than 0, the root is imaginary, meaning there are no roots to take. So how can we find whether this value is, divisible? We go like this: b squared minus 4ac. What is b? Here it is 1. Minus 4. What is a? Times 1. What is c? 1. We get minus 3, which is less than 0. So therefore, we cannot factorize this, right? So another way of seeing whether you can factorize a term is by, looking at its multiples. For instance, look at this: 6. So how can you make 6? You can make 6 by going to 2 into 3, 1 into 6, negative 2 into negative 3, negative 1 into negative 6. It's a positive number, remember? So how can you make plus 5? By adding two of these values. Well, you can go 2 plus 3. That's great. But you might argue, okay, what about minus 6 and plus 6? Well, you would be correct if this was a minus, but that isn't. If there was a minus, then there's only two options how you can get that. Well, there's 4 basically: minus 1 into 6, minus 2 into 3, 3 into minus 2, and 1 into minus 6. And here we can say it's a plus 5, so we can pick this option, right? But similar to that, this is something that is basic algebra, something that you should know before doing a computer science degree. So I would recommend that you go check it all out. There are so many videos out there for partial fractions. I won't be explaining partial fractions much because this is a guide as to what to study. So yeah, go study partial fractions. It's as simple as that. Anyways, have a great day.